This is question 10 from a 2022 reserve paper for A2 Pure Maths from CCEA. So let's take a wee look at what we're asked. In a factory, a biological substance is placed in a large tank. During the production process, the biological substance reproduces at a rate. So that's my rate there. So what's that going to be? Of 0.25 A kilograms per hour, where A is the amount of substance present at a time. So it's going to be a dA by dt type thing here. At the same time, the biological substance is pumped out of the tank at a constant rate of 50 per hour. So if it's being produced at 0.25 A per hour, and then it's leaving then at 50, we're going to have it set up like that. So I'm going to write dA by dt is equal to 0.25 A take away 50. So that's how much is coming into the tank, 0.25 A per hour, and then minus 50. So obviously we're going to try and separate things out here and then integrate. So it's going to be 1 over 0.25 A minus 50, and that's dA, and then that's going to equal then to dt, and we're going to integrate both sides here. The right hand side's easy. It gives me a t plus c. The left hand side, let's have a wee think about this. So say that was a minus 50, then it would just be ln a minus 50, but that's a quarter. So to make that into this, we're going to have to pull in a 4 out the front. So it's going to be 4 ln 0.25 a minus 50, and we have that. Rearranging very slightly here, I'm going to divide everything by 4 and then try and get the rid of the log. So it's log 0.25 a take away 50 equals a quarter t plus a quarter c, and then 0.25 a minus 50 is going to equal e to the quarter t plus a quarter c, and I'm going to let then e to the quarter c equal k and pull that then out to the front. So we're going to have 0.25 a is equal to k e to the quarter t plus 50, and then I'm going to have a equals 4k e to the quarter t plus 200, and that's then what they've been looking for. Sorry, I have a quarter written in there, and it's obviously kind of a 0.25, but we're one and the same. Part 2, at time t equals 0, a equals 190. Show then that we have that. So when t is 0, a is 190, and I'm going to substitute that in then to my formula. So it's going to give me 190 equals 4k e to the 0.25 t, and that's then whenever t equals 0. So that bit then is all going to go to a 1, and so it's going to be then kind of 4k plus 200. And that means then obviously 4k is minus 10, and k then is going to be minus 5 over 2, but it's kind of quite handy. Sorry, I've been a bit silly there, because it's the 4k we're kind of substituting in, and remember our formula here is 4k, so obviously I said it was minus 5 over 2, but you times that by 4 and you just end up with a 10 then as well. So substituting that in, we of course then get a is 200, take away 10 e to the 0.25 t. Part 3. The tank must be completely empty by the end of each production shift. Find the minimum length of time for each shift. Note that a production shift always lasts a whole number of hours, so that makes life easier. But anyway, the amount left in it must equal 0, and the time is what we're trying to find out. So we're letting 200 minus 10 e to the 0.25t, that's equal to our a, so that's then going to be 0. So I would take this over to this side, divide by 10, so if e to the 0.25t then equals 20. Taking logs of both sides, I get 0.25t is ln 20. And put ln 20 in your calculator and times it by 4, and you get 11.98. Therefore, shift is 12 hours. Final bit then, the factory management decides to change to 8-hour production shifts. They plan to manage this by simply reducing the amount of biological substance in the tank at time t equals 0. Find the maximum amount of biological substance at time t equals 0, which makes this change feasible, giving your answer to 1 decimal place. So we're trying to find a whenever a kind of time is 0. So whenever time is 0, and the way we've kind of set it up here, A0, and that's then the amount to be found. So my A0 in this case is going to be 4k plus 200, and the A0 minus 200, e to the 0.25t plus 200. So as you can see, this is us taking into account then our A0, then going down then to there. So they're saying to change it to an 8-hour shift. So that means whenever t equals 8, they want A to be down kind of at 0. So they've kind of gone less than or equal to 0. So that means substituting it into this, we're going to get A0 take away 200. This is quite a tough one, I think. And it's going to be E, so 0.25 then times 8. That obviously just gives me 2, which is quite nice. Then plus 200, and that then has to be less than or equal to 0. Getting the A0 then on its own, you can kind of multiply out this bracket and you get A0 E squared and then the 200 E, but effectively we have our A0 less than or equal to 200 E squared minus 200 all over E squared. So it was just me rearranging here to get the A0 on its own. It might take a couple of lines, we have that, and put that number into your calculator and you get 172.9. Therefore that's the maximum amount. $172.9 kilograms, and that's my answer then to 1 decimal place.